So the assignment for this topic of chemistry is as follow. These are the objectives. I want you to practice the shorthand notation to be able to identify number of neutrons with the little formula that we've talked about, to identify the most abundant isotope or chief element, understand the relationship between atomic mass and isotope abundance, and lastly, to be able to calculate the weighted average of isotopes and distinguish it from the atomic mass. Check it out. I give you a small recap in here, very detailed, in a very detailed manner, so you have no questions. And if you have questions, you can always come back to this part, check it out, and I'm pretty sure you're going to be able to clear um, your doubts. Shorthand notation, we've already talked about it. Here's the little formula. You need your chemical symbol, you need the mass number, and you need the atomic number, just like carbon. In order to calculate number of neutrons, you follow this relationship, this small formula, right? Subtract the atomic number from the mass number, and voila, you've got your amount of neutrons. To identify the most abundant isotope, I've given you a little table with all the information of the different isotopes that they have been able to identify, right? It's giving you the atomic number, the name, the symbol, the atomic mass, plus the relative abundance of each one. There are some that are virtually negligible, right? And unexistent. If that's the case, you simply don't utilize them. And there is also the case of some atoms that don't have isotopes, right? You should take that into account as well, right? So you're going to be using this little table a lot. Let's go back to the explanation. Instructions, right? For instance, carbon has two common isotopes, carbon 12 and carbon 13. The atomic mass of carbon is 1201, so the most abundant isotope is carbon 12. Does that make any sense? Quickly, you can reason it like that. The atomic mass is 1201, and it's closest to carbon 12, the mass number, than it is to carbon 13. So you can safely assume that carbon 12 is the most abundant one. But you don't need to be assuming all that much right now, because you have the little table in here, and you can check the percentages of each one of the isotopes. Right. Using atomic mass to identify the most abundant isotope, right? You're expected to explain that atomic mass is a weighted average of all the isotopes. So they take all the isotopes and they do a weighted average of them, and they reflect the relative abundance of each isotope as well. The closer the mass of an isotope is to the atomic mass, the more abundant that isotope is, just as we mentioned with carbon 12, right? And we also mentioned about chlorine. Remember in the previous example? So the atomic mass, that is to say the weighted average of all the isotopes of chlorine, is 35.45, right? And if that's the case, which isotope do you think is the most abundant one? Chlorine 35 or chlorine 37? Well, the closest to 35.45 is chlorine 35, and thus that's your answer. That's the most abundant isotope, right? In order to do a calculated weight average, you need you're gonna add up the products, just as we talked before about it, by taking the mass of the isotope and the relative abundance changed into fractional way. That is to say, changed into decimal. We're going back to the same example as previously. 75.77% of chlorine belongs to chlorine 35, that isotope, and 24.23% belongs to chlorine 37. You take the mass number of each one of the isotopes, and you turn the percentage into a decimal. Multiply it, add the products, and you get yourself the weighted average. This is expressed in atomic mass units. Great. Lastly, distinguish between weighted average and atomic mass. You should you should take into account that there is a huge relationship, just as we have been discussing, between these two. So, weighted average reflects the real world distribution of isotopes, while atomic mass is a rounded value represented the average mass of an element's isotopes as found in nature. Now, here's some examples of the things that you need to land. You can either do it like this, or you could do it as a little table that I've done for you, because I think this is faster, um, and it's more space saving as well, right? Let me just finish this. So we're doing it with carbon, 12 carbon 13. The atomic mass is 1201, so the most abundant isotope is carbon 12. The atomic mass is closer to 12, meaning, well, that carbon 12 is the most abundant. The weighted average calculation, right? Well, we know how to do it. You take this one, you look for the percentage of each one, 98.93. That is to say, you will multiply 12 times 0.9893, 13 times 0.0107. You multiply that, you add them, and you get yourself the weighted average. Right? Here's a little checklist so you can see what I'm going to be looking for in your job, in your little assignment. Now, this is an example of how I want you to fill the table. You start with the element name, obviously. Then I want you to do the shorthand notation of all the versions of this element. That is to say, all the isotopes. In hydrogen, we understand that there are three: hydrogen 1, hydrogen 2, hydrogen 3. Okay? What is this telling us? Again, the mass number tells us, well, in the first one, because we only have one proton, and they're telling us we have one. If you subtract one from another, that means that we don't have any neutrons, which is the real case. There aren't any neutrons on hydrogen 1. But what happens in hydrogen 2? If you subtract it, we get 1 neutron, and in hydrogen 3, we get 2 neutrons. Mass number of each: 1, 2, 3. You landed in there. The atomic number of hydrogen is 1. Neutrons, we already did the little calculation. You need to write it down in this column by following the formula. Mass number minus atomic number. Now, which one is the most abundant isotope? Well, in here, you're going to select the isotope and write it in shorthand version of the most abundant version of this atom. Right, in this case is this one. You can check the percentage, and that's it. Moving on, atomic mass of all the different isotopes. Right, you can get that information as well from here. Atomic mass of each one, you write it down, and then the relative abundance. I've already explained that some of the values in here are negligible because they're virtually non-existent, right? If that's the case, you don't need to include them, obviously. And then the weighted average calculation. We've been discussing how to do this, right? You take the mass number, or better yet, you take the atomic mass of the isotope, you multiply it by its relative abundance in a fractional way, turned into decimal. Right? You add them up and you get the weighted average calculation. Explanation between these two values. The atomic mass is close to 1008, reflecting the abundance of this isotope. That's it. That's the information that you need to look for in each one of the elements. I hope this video is helpful, and any questions, you let me know.